Hello everybody. I'm Paul Heisterkamp. I'm a fast-track recognized solution architect working for GWS in Germany. And I'm presenting you a session in the Dynamics Con format. Thanks for letting me in here. And I want to show you how to empower your development process by using Git for your F&O apps. I'm working for GWS since 2009, so almost 10 years now. I've started in 2009 with developing NAV. This is now called Business Central. Then I moved over to F&O at 2011. And I'm now there working as a solution architect. And I'm in the F&O ecosystem, so the formerly known AX7 or Dynamics Renier since the very beginning. And in 2018, I started blogging. And one of my favorite topics is application lifecycle management, so ALM. And this Git thing is part of the ALM story. When I'm not working, so the private aspect of me is I have two childs, actually two daughters. One is 3.5 years and one is 5 days old. So I love to play with them. Going to the agenda, I first want to show you when you should use or when you could use Git and when not to use Git, of course. Then I want you to understand one key difference between Git and TFVC. Then I show you how to set up the development environment. And with this setup, we compare the TFVC and the Git process flow when developing F&O extensions. Then I want to show you how to switch branches. If we have enough time left, I show you some details for setting up your build pipelines with Git. And then I'm closing with the key benefits of using Git. But first, we have to start with a disclaimer. We need this disclaimer because Git is not officially supported as the version control system for F&O by Microsoft. But to be honest, there is, or in my opinion, there are other programming languages that are also not supported or not officially supported, because Git is your version control system, and yeah, whatever you are able to use Git, you can use it. Officially supported for me means more that you are able to use multi-branches, multi-repositories, and so on. Officially supported also means that you are not able to create support requests when you're having problems with Git and F&O, but I haven't created any support requests for the TFVC part of the version control for F&O. So I think this is not a blocker, and if you're having any problem, you have a nice community and you can ask everything there. For the background, we're at GWS using Git as our version control system for F&O since I think 2018 or something like that, or 2016. And for the implementation projects, we are using it since I think 2 or 3 years, maybe 4. And we started using Git after we get rid of the overlaying, and because of that, we didn't use the code upgrade service anymore. And so then we were able to use Git also in implementation projects. So when to use Git and when not to use Git. So I would want to start with the introduction for when not to use Git, so when to use Team Foundation Server version control. And I would think if you're doing a project where you're only having binaries and you have a very small part or a very small development budget and a very small development team, you will not benefit from Git that much. And if you're then also not that familiar with Git, because Git is somehow different than TPC, then I would not recommend to use Git. And of course, please do not use Git in an implementation project if you haven't used it before for internal developments or to get used to it. Yeah. And if you still need the code upgrade service, this is the service that identifies your overlayings and injects work items into Azure DevOps. If you still need this code upgrade service, I think there is no need for this anymore, but maybe you will need it, then you're also not able to use Git. Then now on to when to use Git. You can use Git, or you will benefit from the Git flow when you're having a high development effort or a high development budget. So you're doing a lot of customizations, a lot of extensions, and you have a large scaled development team. Then I think it is good to use Git because you have a better ALM story and a better development process story. And of course here, please only use Git if you're familiar with the base concept and the operations of Git, because there will be some point in time where some of your developers ask, I have a problem here with my Git integration, how to handle this. And then you should be able to help your team. So the next thing would be one key difference between Git and TFVC. TFVC on the right side is a centralized version control system. So whenever you're doing something with your version control, so with your repository, you're talking to one centralized repository. If you're using Git, the left side, then you have a clone, so a copy of the centralized or the central repository at your local VM, and you're first only talking to the local repository. And there are, of course, commands to publish or push changes to the central repository. But if you're only doing local operation, then everything stays local. This is a benefit when Azure DevOps is down. This is not that usual, but it can happen. If Azure DevOps is down, you are not able to use your TFVC repository, but you are able to use your Git repository when you have cloned it before to your local VM. So now we start with the setup of the development environment. First, I want to show you how you create and set up your repository. Then I'm helping you, or I'm telling you some, or I'm showing you some Git UI clients for your choice. Of course, you can use the command line for Git. This is more for the hackers, I would say. I'm using a Git UI client. Then I show you how you map your repositories to your AOS folder. And yeah, we're digging a bit into the repository, what's in there after build. And then I show you how you create a new model. So now we go into the demo. Here is my Azure DevOps project where we do some prototyping and so on. So this is called Kavete. When you want to set up your repository, you can do it here under repos, and here at the upper side, you can create a new repository. Just for your knowledge, if you're having an implementation project and you want to deploy and build server from lifecycle services, you would need an TFBC repository. I switched to this one, but it is a very simple TFBC one with trunk main, metadata, and everything is simply empty. But this connection is needed to deploy and build server. When we are switching to the Git one, you can have multiple Git repositories. So if you, for example, want to separate different ISV solutions in one Azure DevOps account, you can have multiple repositories. I can show you one example from our ISV development. So this is another Azure DevOps account for our ISV solution. And if I click here, you're seeing a lot of repositories. And each repository is, of course, separated from each other. Then the structure of the repository, I would recommend that you have metadata folder, and then in this metadata folders, the packages you want to have under version control. In this case, we're having only one package in here, so it is the Kavete suite. If I'm clicking here, then you have the model folder in here and the descriptor. Descriptor is, as you know, from TFBC, and here's the normal model folder. Of course, you can have more models. I show you down here. So if I'm going here and going to metadata, there are a lot of packages in there. Then one important part is the gitignore file here. The gitignore file contains the files that are ignored from version control, because in this metadata folder there is the result of the compile, and you do not want to check in this this file that's coming from the compiler. And to ignore all this, this is an example, and I know that Nathan also has a good example in his repository, and you can also find my repository on GitHub and copy the gitignore file from there. So this is the base structure. If you want to create a new repository, you can do it like this. Then you can add an gitignore file or simply an empty one, type in a name here. I'm using dynamics-con, simply create the repository, and now you have a repository here. I'm switching back to my Kavete repository, and this is the online representation of the repository and also the history. And now we're moving on to selecting an Git UI client. I'm normally using Git extension or fork. Git extension is an open source project and it is completely free. Fork you can use without buying a license, but if you want the full application, you can buy a key, but it is not that cost intensive. so it is worth the license. Now, once you're in here, you can select the repository. How you create this one, we will see later. If you're selecting a repository, you're having an history here at the right side. At the left side, you're seeing some branches. And this is the Git extension representation of this repository. And if I'm switching to fork, I'm having the complete same repository here. So that is a bit, yeah, it has a smoother, more current UI design. So my favorite currently is fork, but you can also work with Git extension. So once you're you have set up your repository, you can clone the repository to a local folder. So this is the part where you copying over all the complete repository information from the centralized repository to the local one. And I show you how you can do this. If you're having your repository here, then you have a clone button up here. You can copy this one over. And if you're using Git extension or fork, that doesn't matter. Both have a clone repository button where everything gets pre-defined based on your clipboard. And I'm doing Kavete Dynamics Con. So this is the subdirectory. This is the root folder, and then you're good to go. You can clone this one here. Now it's asking me if I want to switch to this repo, and now here I am. So this is the local copy, and yeah, we're having some origin. So this is this centralized view and some origin branches here. So when you now want to start developing, you can go to your repository folder. Then you have this Kavete Dynamics Con folder, and here is the repository. I have a Kavete suite in here. Here is my repository folder. I'm deleting the old one here, and now you can create a symbolic link from your repository to the AOS folder. You can find the register symbolic link, PowerShell script, and unregister symbolic link in my GitHub repository. I'm showing you here the internal cmdlet. It is register gvis packages, but it's doing almost the same as the one in my repo. So when I'm doing this, it tells me I have mapped Kavete suite. And now the symbolic link is back again here. And when I'm now going to my Visual Studio build dialog, I have the Kavete suite package in here, and I can click and build this one. Just to show you that I'm not kidding here, I'm deleting this symbolic link, restarting Visual Studio, and now when I want to build the Kavete suite, it's gone. Oh, it's gone. And now I can remap this one, then it's back, of course. And I'm doing refresh models, build, and here it is. So now when I now build this one, the result of the build will go into my metadata folder. So currently it is quite empty in here. And I'm now building my Kbeta suite. It will place everything in the repository, but because of the git ignore file, it will not put it under version control. We will let the build run, and I show you, or it is just finished. That one was quick. And now you can see in the metadata folder, so there are the build result, the bin folder. So there are quite some files in here, but yeah, when we are looking into the pending changes, you can see here, there's nothing in. So that is all ignored by the git ignore. The beauty of this symbolic link thing is that you can easily add additional repositories or just throw them out and test without them and then remap them, and you do not have to compile again or something like that. You just map and use the latest build result. Now, one additional thing in this topic, I show you how you create a new model or package. I will create a new package, DynamicsCon. Publisher is me. I'm creating a new package. I'm only referencing application platform. So now it is creating the model and seeing this one here. And now the only thing you have to do is cut this one, go to your repository, DynamicsCon, metadata, paste it in there. Okay, it should almost be empty. Now it is over there. So you have the descriptor again here. And to create this symbolic link again, we're opening PowerShell, register. Oh, I want register this one here. It tells me that I'm registering DynamicsCon. The upper one is because I already have the Kbeta suite mapped, and the script is not intelligent enough to skip this one. But when I'm going to the AOS folder again, then I have a symbolic link for the DynamicsCon. And when I'm now going to the pending changes, you can see I have the descriptor as pending change. This one was the setup, the development environment. Now I want to compare the TVC process flow with the Git process flow. A simple example, mapping the workspace is the equivalent to clone repository and create symbolic links. So before you start developing, you have to map your workspace. This one we have seen. Then with TVC, normally you do not make a development branch for your developments. With Git, this one is mandatory. Then you exclude include your changes after you're changing something. Here it is called stage unstage. Then you can create a code review. As far as I know, it is not mandatory, and you cannot activate it to be mandatory via policy. With Git, it is a pull request, and you have to do it. And then you're queuing in gated check-in for TFVC. Here it is again the pull request. So pull request includes a build. And then you're checking in with TFVC, and with Git, when you're completing the pull request, it is committing the changes and merging it into the target branch, and then you're doing get latest version, and with Git you're doing checkout and pull, so that you're getting the latest version to your local branch. So first we're kind of cleaning up the stuff here. Now I'm mapping my Kavete repository again. There it is. And I'm opening the Kavete one. So this is when you stopped your last development. Yeah. And now you have to go to the development branch to create a new individual development branch. In our case, our base version, so the release is our master branch. And I'm doing a checkout here, and up here a pull. So now I'm getting the latest version to my local repository. And now when I want to start the development, I have to create my own development branch. So in my case, HKA is my user ID on now Dynamics Con. This is the branch name, and you can see here's my branch. But this one is only locally, and if you're going to Azure DevOps, you will not see this one. Now I'm opening a solution for this Kavete suiting, and this one is simply not good formatted. So I will format it better, save it, and now you can see that I'm having a pending change here. You can see the diff, of course, and now you can stage and unstage your changes. This one is include, exclude changes in TFVC. So this one is unstaged. Now I stage. Now, of course, you can now change this file again, and you will see the difference between your staged and the unstaged version, but this is too deep, I think. Now I have this one staged. I can type my commit message from Dynamics Con, and I can commit, or I can commit and push. Commit is only locally, push is to the remote, so the central branch. I will only commit because I want to show you one thing here. I'm having this locally, and when I now go to Kavete, there are only this branches visible at this centralized Azure DevOps account. So there is no Dynamics Con branch, and once I'm clicking here, here's so this branch gets pushed. I'm pushing this to the Azure DevOps account. Then I get noticed here that I've updated a branch, but you can also see it here. This is my branch, and it is now published or pushed to the Azure DevOps account. Then the next step would be a pull request. This one is easy here, or you can go here and create new. I'm doing it from here. So I'm doing a pull request from my branch into the master branch. This is a message you can assign reviewers here, or you're using a policy that auto assigns reviewers, or you can put a work item here. I'm letting it like this. Here you can see the files and the commits, but this you can also see later on. I'm creating the pull request, and now this one is the code review part. So the reviewers can add, you can add optional and required reviewers. So your colleagues from the development team will review the files, and they comment here, this is not good, for example. And this one you can see here. And once everyone is okay with this, we can approve this one, and then you get approval. And once you have enough approval for this pull request, you can complete it, and then it gets merged into the target branch. You can set up that you want 2 approvers or 3 or 4 or only 1. It depends on you. Now what you're also doing here is you're doing a build. You can see it here. So in the build, you're doing, of course, the build solution. So this is the compiler test, but you can also do unit testing or ATL testing. So every pull request will include the unit testing part. So once this pull request is approved, you can click complete, or if you are authorized to override, then you're override message. Then you can complete whatever you want, and you can check the checkbox here, delete your development branch after merging, and you can also customize your merge message here. I'm doing this here, so I'm completing this pull request. So this one now will go into the master branch. But I'm not seeing this change here because this one was only at the remote. And I can fetch and prune all branches here, and then I'm seeing here. This is the commit message of the master branch, and you're seeing here that you're 2 commits behind. So I can check out the master, pull the latest version down, and now I have all changes again locally. Of course, now you maybe have to compile the package again, because maybe there are other developers that checked in changes, and now you have the latest version. So check out and pull is the equivalent to get latest version. Okay, we go on to the next slide. This one is how to switch branches. So if you're using a similar branch structure like this one at the right side of the slide, you have a master. So master at the release level, development is ongoing development, and then you're having feature or prototyping or hotfix branches. You're starting the development as I showed you before, and then you're doing a new, or you're publishing a new feature branch, and of course, not only you is able to work on this feature branch, you're able to work on this feature branch with a bigger development team, but it is also possible that in the development branch, there are also changes. And it could be that you would want to reintegrate this development branch in your feature branch. And I would want to show you how you do this. For example, if I'm having a feature branch like this one, yeah, this one here, and now you want to, so you're working here at this branch level, and you want to reintegrate the latest version from master. You can do this with Git extension if you check out the master branch. And then, oh no, you have to check out this one and merge master into your destination branch. So this one, merge. So in this case, there is a conflict. If you want to resolve this conflict, you have an you get this dialog. You can merge. This one is a good example of the three-way match, and I want to use yeah, let's say this one, and this is C. Now save. Okay. Do you want to commit now? Yes. So now I'm having the latest version here, or the stage changes, and you can commit and push these changes to your feature branch, and then you're back up to date. Of course, this feature branch can also be used for prototyping or other branch strategies. If you want to develop a hotfix, you can use, let's say, the master branch of a specific version and create a branch there. So you're completely open for branching here. But also, if you want to test on a specific branch, you of course also need a dedicated environment for this. So a feature branch where you want to test on, then you will have to have an additional separate environment. If the feature branch is only for a cooperated development, and you do not want to integrate this one directly into the development branch, you can use this feature branching strategy. The next one is a very important one. It is the setup of the build pipeline. With Git, you have the option to use the classic CI build pipeline here at the upper part of the slide, or you can also use a YAML build pipeline. And a YAML build pipeline is that you structure or describe your build with a YAML file that is also under version control. So you're versioning the setup or the structure of your pipeline, and when you want to change the pipeline, this is also including a pull request. So you're validating the changes to your build pipeline with a build, and this is perfect. I can show you those differences shortly. So I'm first showing you the classic CI pipeline. So this one is the Git one. I think you all know this structure. You have a get source from, for example, master, then prepare for build, set build version, build, and so on. But this one is not under version control. And when you now use a YAML file for this one, you can do this under version control. So here at the upper side, you see the branch. For example, this one is the version we're having in the master branch, and you can also have other branches. And for example, when I'm going to my feature branch, I can change, for example, the a typo here, or add a test in here, and now this one can go to my branch, and I can create a pull request for this one and validate the change. The whole thing here is simply the steps that you're having in the classic CI pipeline in YAML style build steps. For example, generate package here is almost the same as this one here. Here I'm using the task template from Microsoft, and here it is the pure PowerShell task, but you can also add a PowerShell task here and use the same command. So when you want to move your classic CI pipeline to YAML, you can simply copy it over and add tasks here. Here, this all is PowerShell, and you can also add a PowerShell task here, like this. There you have a PowerShell task, and the input parameters and the script path you can copy over from the classic CI. So this is a major benefit of the Git, because with TVC you are not able to use a YAML pipeline. So now the key benefits for using Git, I think it is more flexible for multi-branch usage, and multi-branch usage is a key benefit if you're doing prototyping or developing the fix for bug A and are not yet finished, and you want to switch back to the current development base and then do a hotfix for, let's say impediment C. You are able to do this, and you do not have to delete all the workspaces. You only can switch branches if you want. Then the next thing is the pull request. I think pull requests are way better than code reviews. Code reviews are always kind of hidden, and as I said before, they are not mandatory. So if a developer forgets the code review, of course he gets blamed or have to pay cake or something like that. But the pull request is mandatory, and you cannot get around it even by mistake. And then the build using YAML files is a major improvement. For example, if you're using your central CI build pipeline and you're destroying it, then your build is broken. And with YAML, you change this definition in a development branch, and then you can validate it with a pull request. And only when it builds, you can check it into the master or to the development branch. So this is a major improvement to the classic CI pipelines. So if you're having any questions or input or feedback, or you're having problems with your Git integration, feel free to reach out to me. You can contact me via my email address I showed at the very beginning, or you can ping me via Twitter or LinkedIn or Yammer. So feel free if you're having any problem with this kind of integration. Thank you.